So we're looking at the chapter review for chapter 4. That would be congruent triangles. So the methods, the 5 are side, 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 angle, angle, side, angle, 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 side, and hypotenuse, leg. These are all triangle congruence theorems. Those are all the ways we can prove triangles congruent, and the ones that don't work are side, side, angle, and angle, angle, angle. So these are the 5 that work. That's what we use. This is a really important question. The idea of what inference can we make from a piece of information. So the fact that xz bisects this angle, we can make an inference. Let's make sure we don't make the wrong inference based on that. Okay, so what I like to do is follow the path of yzw. That's this full angle, y to z to w. When it's bisected, it cuts it into 2 equal halves. So then angle 1 is congruent to angle 2. That is the only conclusion from this statement. Okay, there's possibly other pieces of information that are true, but that's the one from this. Okay. BE bisects AC. The order sometimes gets messed up by my students. AC is what is being cut in half. We don't know if BE is. It probably is, but we can't conclude that. Look at AC. It goes from here to here. We know now that that's cut in half. So AE is the same as CE. Okay, so that one right there. That's our true conclusion for sure. All right, BC is parallel to AD. This is very tricky, this one right here, okay? Oftentimes this is messed up because we use the wrong parallel lines cut by a transversal. What we have to understand is AD and BC are the parallel lines, and it's cut by transversal BD. So if we just extend those, okay, what we got to realize is, and this is A to D, right? So we've got angle 6 is right there, right? Think about that. So angle 6 is right here, okay? Now that is alternate interior, there's B. That is alternate interior with this angle right here, which is angle 3. So the congruent ones are angle 6 is congruent to angle 3 from this piece of information. Now, my trick is with students is look for the N or the backwards N or the Z, and let me highlight that. So here's what I'm looking at right now. This is a backwards N. And what I teach them is the inside corners are the alternate interior angles. Okay? So that one we can guarantee. Angle 6 is congruent to angle 3 for sure. Okay. AB is parallel to CD. AB is parallel to CD. Okay, so right there, we got to draw the arrows. That does not mean the sides are congruent. It just means those are parallel. Okay. Now, which angles are congruent as a result? Here's what you got to look for. Right there. Follow that. Are you noticing the backward Z? Inside corners of the backward Z, that is going to be your congruent angles. So we can conclude for sure that angle 1 is congruent to angle 7, and that's because of alternate interior angles. And I'm writing this so that we can get ready for proof. Alternate interior angles are congruent when parallel lines are cut by a transversal. Now, if your teacher allows you to say alternate interior angles theorem, go ahead and do that. That's sufficient. All right. If they ask you to write it out, there it is written out. Okay. Now, if FB is parallel to ED, that's this. Wait a minute. FB. Where's FB? Oh, right here. Sorry, I was struggling to find that one. Okay, so FB is parallel to ED right there. And here we go again. Think about the backward Z inside corners. backward Z, inside corners. So that is angle 4 is congruent to angle 9. Angle 4 congruent to angle 9. And for the same reason as that one. All right? Again, it's by, I'll shortcut it this time. This is alternate interior angles. And we could say are congruent when parallel lines are cut by transversal, or if your teacher allows it, alternate interior angles theorem. All right, let's get rid of some of this stuff. Now, the fact that start over with angle 5 is congruent to angle 11. Angle 5 is congruent to angle 11. That's a little strange. AF is congruent, there's F right there. Okay, AF is congruent to CE. FB is parallel to ED. FB is parallel also to ED. Okay. Now we got to prove triangle. Let's highlight it. FBC. FBC. FB. Okay, this one right here. So see the one off to the side? They want us to prove that that's congruent to EDA. All right. So what are we going to be looking at? Let's start with the markings. Okay, this is going to be tricky, but we can get FE congruent to itself. So what we're looking at is, I'll bet I can get FC. I can get FC the same as EA. It's going to take a little work, but I can get this side here the same as this side from here to here. Okay, that's going to give us an S when we get there. It's going to give us one S. If we can get a couple of angles, we'll be all set. And I think we can. They're giving us angle B is congruent to angle D, and this is not a full proof. This is just my scrap. There's an angle. I like it. Now, from this parallel lines idea, I'm thinking, again, that backward Z trick, I think we can get angle 4 congruent to angle 9. And that's going to get us another angle. Now, what I teach my students is I write the two. If we have two of one and one of another, I like to write that first. I like to write those two first. Now, as far as the side goes, we don't know whether it's going to be at the end or in between. So now we have to look. Okay, if we just focus on this purple one, there's the two angles, but it's not the side in between. It's the side that's not in between. So we put the S there. So this is what we should do with our pre-proofing process. Figure out what we have and what we can do with it. Okay, so now we know that it's going to be an angle-angle side proof. So that is what we hope to look for. And oh, that's nice. They even gave us some of the proof. Okay, so now we got to try to follow their path. 5 was the same as 11 because it was given. It gets us a pair of angles right off the bat. AF is congruent to CE. All right, that's given, but we don't have a pair of angles. I'm sorry, a pair of sides yet. What we have is, this is reflexive right here. This EF is congruent to EF. I probably should switch the order, but I'm not gonna. That's reflexive property. Okay, that's when that piece of the side is congruent to itself. Now we got to do segment addition postulate. Okay, segment addition postulate. We haven't done that this year in my class too much, so I'm going to be pretty relaxed on that. Basically what we're going to say is C to E plus E to F, okay, is C to F. There's going to be a couple steps here. C to E plus E to F. So this is going to be a little weird. You're looking at, so C to E plus E to F, right? That should be equal to A to F plus E to F. Basically, you're adding things that are congruent, right? So you should be able to get away with that. And because of that, if you see C to E plus E to F, that's the same as CF. Okay, this really should be 2 steps, but they didn't put it in 2 steps. So C to F now is going to equal A to E. If you combine these two, they give you C to F. If you combine these two, they give you A to E, and that's kind of like second addition postulate. So right now we have C to F equals A to E. That gets us an S. All right, wasn't the greatest. I would have split that up into 2 steps if it were me, but you know, we'll just follow what they have. Good enough. I believe this was given, and as a result, we're going to get those alternate interior angles, and that was angles 4 and 9. Angle 4 is congruent to angle 9. And this is up to your teacher stylistically. I'm going to write it out, but theorem's going to be okay here. So it's alternate interior angles are congruent when parallel lines are cut by a transversal. Now, this is because of our angle, side, triangle congruence theorem, or postulate, whatever your teacher used. All right, that's it for the first session, and good luck.